So today's lesson is going to be looking at solving the equation of a line given 2 points. So there's several different forms of the equation of a line, so we're going to look at those forms of the equation of a line, and then we're going to look at how to solve them. So the first is the equation of a straight line in slope-intercept and slope-point form. So y equals mx plus b is the equation in slope-intercept form. So we've seen that m before. M is the slope. And we've also seen b, but maybe not so recently, so quick reminder, b stands for the y-intercept. What does the y-intercept mean? Well, that's the value where it crosses the y-axis, or you might say it's the value of y when x equals 0. The point slope form we have definitely not seen before. Y minus y1 equals mx minus x1. So m is still the slope, and the point y1, x1 is any point on the line. So when you put something in point-intercept form, there's going to be a lot of possible equations because there's a lot of different points on the line. In fact, there's infinite points on the line. So it's any point on the line. So once we know 2 points on a line, we already know how to find the slope, and we can take that slope and use it to write the equation now in point slope form, and we can rewrite the equation into slope-intercept form, which is a very common one we want to go to. Occasionally though, we want to go to 2 other forms. One is standard form, which is ax plus by equals c, and a, b, and c have to be integers, so no fractions in standard form. And general form is ax plus by plus c equals 0, so the difference between these two is pretty subtle. Here our variables are on one side and the constant c is on the other side in standard form, and in general form everything's on one side and equals to 0. The other difference is a has to be a whole number, so positive in general form, whereas in standard form it's okay if a is positive, but it's also okay if it's negative. So we're going to do a couple examples going to each one of these forms given 2 points on the line. So first example, find the equation of the line passing through 2, 0 and minus 3, minus 15 in slope-intercept form. So first step is determine the slope. I encourage you to pause the video, calculate the slope yourself, make sure you're on the right track. So we calculate this slope, and I'm just going to bring this over here so you guys can see what I'm doing. So we put in these points, which in this case is going to be minus 15, subtract 0, over minus 3, subtract 2. Careful with your signs as usual on these. So we get negative 15 on top, negative 5 on the bottom, don't know why the color suddenly changed, and 15 divided by 5, negative divided by negative, gives us a positive, so we end up with an overall answer of 3 over 1. So that gives us our slope. That's just the first step. So now we take that and we plug it into the equation of the line in point slope form. So that's us y minus y1 equals mx minus x1. Now this is a little tricky in that some people get mixed up. What am I using for my point? It doesn't matter which point you pick, either point's going to work. So this first example I'm actually going to do with both points. First with one point, then with the other point. The other tricky bit here is that sometimes people want to replace both y's, but the first y that doesn't have a subscript stays as y. The second y comes from one of our points, so it doesn't matter which point we pick, so first we're going to use this first point. So our y1 is 0 on this one, and if you have a 0 that often simplifies things. You'll see this one works out a little quicker. Our m we said was 3 over 1, or 3. Our x, just like our y with the subscript, the x with the subscript stays. And our x1, since we took the 0 from this first point, we have to take the x from this first point as well. So that becomes 2. So that's our first step. Just plug those in. That is actually the equation of the line. But this question specifically asks us in slope-intercept form. So slope-intercept form is y equals mx plus b. The y is all by itself. So this case we have y minus 0, so y is actually going to be by itself. Mx plus b has no brackets. We've got to get rid of those brackets. So 3x minus 6. Right? Distribute the 3 to the x, distribute the 3 to the minus 2. So this one, we actually have a kind of a shortcut because we're already in slope-intercept form. Some questions we're going to end up having to work a little longer than that. If we look at the second possibility, this is going to end up being a little longer, because if we take the second point, our y2 is negative 15, m is still 3, the other x minus 3. So it doesn't matter whether we put in the first point or the second point and call it y1 and x1. But this does end up being a little bit longer in this particular case. So x plus 15, because we're subtracting a negative. And again, on the other side, change that subtracting a negative to a positive. Next step is going to be get rid of those brackets, because this time we do have stuff on the other side of the y, same side as the y, I mean. We're going to have to do something with that as well. So y plus 15 equals 3x plus 9. It's only in slope-intercept form when the y is all by itself, so we've got to bring that 15 to the other side. And then get those like terms together. Notice that when we do this, we end up with the exact same final result as when we put in the other point, but it took us a little longer. So when you get to the step where you're plugging your point in, sometimes one point's going to be a little easier than the other, and it doesn't matter if it's your first point or your second point. You can take that and use whichever one you think is going to be the easier one to put in there. Okay, so that's the only one I plan on doing both points. When you go through the next ones, if you try it with the other point besides the one that I pick, you'll see that it doesn't matter which one you put in. Okay, so the next one, find the equation of the straight line passing through 2, 4, and 3 minus 5. So again, our first step, determine the slope. So I'm going to have to scroll this up a little bit so that we have the point where I can see it. So negative 5, subtract 4, over 3 subtract 2, which is going to give us negative 9 over 1. I didn't deliberately end up with some questions that ended up with whole numbers, but we did, so that's okay. Minus 9, integer. So now we plug that into our equation of our line. So y minus, doesn't matter which one we pick for y1, but then we're going to stick with that. So I'm going to use the first point, y minus 4, whoops, just 4, equals, well, our m we said was minus 9, and then x minus, so since we picked the 4 for our y, we have to pick the corresponding x, so the 2. This time we're aiming for general form. So general form has no brackets, no fractions. Y minus 4 equals negative 9x plus 18. And we want, for general form, everything on one side. And we want it to be the side where x is positive. So we're going to move everything to the left side in this case, so we get plus 9x plus y minus 4, and when we bring the 18 over, it becomes negative 18, and that equals 0. So like terms together again, 9x plus y minus 22 equals 0 is our standard form. right? And we can check back up again, see how, I said standard, but we're looking for general form. Our general form, right, everything's on one side, A is a whole number, B and C are integers, so that works. A is 9, B is 1, C is minus 22. I often get asked, what do A, B, and C mean? And all on their own, they don't really mean anything, but there's many applications where they might mean something for that particular application. There's things that allow us to get to where we need to go. Third question, we're aiming for standard form. So pretty similar to general form. So again, we start out, find the equation of the line. Find the slope. So let me put that in there. So we get 15 minus 5 on the top, negative 3 minus 17 on the bottom. Whoops, missed my equal sign. Let's fix that. So 15 minus 5, we get 10. Negative 3 minus 17, negative 20. So this one works out to a fraction, and a negative fraction at that. 1/2. So we get that equation, that value, and now we can plug it into our equation in slope-intercept form. So again, slope-intercept form, y stays as y. Pick which point we want to use. So I'm going to use the first point again. So y minus 5 equals, well this time our m's a fraction, 1/2. Don't forget the negative. X stays as x, but x1 becomes the corresponding one to our y. So y was 5, x is going to be 17. So this one's going to be a little trickier because we have fractions to work with, but that's okay. So y minus 5 equals, same step again. As we did in standard form, we got to get rid of those brackets. You'll notice for all these, we got to get rid of the brackets. So we distribute that minus 1/2, we get minus 1/2 x. It would help if I could somehow type this. I don't know why that just happened. Okay, minus 1/2 x minus, and then negative 1/2 times 17. So we're actually going to get a plus there. And remember, 17 is like 17 over 1, so when we multiply it by 1/2, we get 17 over 2. So for the standard and general form, when we end up with fractions like this, our next step is actually to get rid of the fractions. So we're going to take this whole equation, and we're going to multiply it by 2 to get rid of the fraction. So remember, that means distributing the 2 to every single term on each side. So when we distribute it on the first side, we get 2y minus 10. When we distribute it on the second side, we get negative 1x, or just negative x, plus 17, because the 2 cancels out with the 2 in the denominator. So now we don't have any fractions to deal with. We can work on getting it into standard form. So standard form, remember, is variables on one side, constants on the other. So that means we need the x and the y together and the constants together. So I'm going to move the x over to the same side as the y. So we're going to get 1x plus 2y plus 2y. And I'm going to move the 10 to the side with the 17. So remember, it changes sign. So I get 17 plus 10. So now I'm going to get 1x plus 2y. No like terms there. I'll leave them separate. But the 17 and the 10 gives us 27. So now I have that one in standard form as well. So note, once we get to standard form, variables on one side, constants on the other, no fractions anywhere. So there was 3 different variations there, but we're starting out the same way every time, and our steps are pretty similar. So I've got a little recap here of our steps. First, every single time we determine the slope. Second, every single time, regardless of which form we're aiming for, we start out with the point slope form. The point slope form is what allows us to get to where we're going. So we hardly ever want to end up in point slope form. It's a step to get us to where we need to be. We rearrange then is our final step, but that rearranging depends on which form we want to end up with. Every single time though, we started with expanding the brackets, and then our A, B, and C here is depending on which we were aiming for. So when we wanted slope-intercept form, we had to isolate the y by bringing everything to the opposite side. If we wanted to aim for the standard form, we multiplied to get rid of any fractions after doing the expanding brackets. Then we brought variables to one side, constants to the other. If we were aiming for general form, again, we started by expanding the brackets. We multiplied to eliminate any fractions. And lastly, we brought everything to the side that made x positive. So there's two special cases of lines, and that's our horizontal and vertical lines. Remember, horizontal lines have a slope that's 0. They're not going up or down. So for those ones, since the slope's 0, if you think about that y equals mx plus b, if m is 0, that part's going to drop off. So you just get y equals b, right? The mx is gone because it's 0 times x. Vertical lines, a little trickier in terms of thinking about that conceptually, because they have that undefined slope. So we really can't use the point slope form at all. But we can show a vertical line as x equals a being the x-intercept. Now a little hint here is whichever coordinate stays the same in your 2 points, that's the variable that ends up being in your equation. So if we look at example 5, we have a point 12, 12 and 12, 3. The variable that stays the same is the 12. And both of those are in the x point. So that equation is going to end up being x equals that constant, 12. In the second one, we have minus 1843 and 543. So this is our one where if we go y1 minus y2, we're going to get 0. Our slope is 0. So this is looking at our horizontal line. Y equals 43. Now sometimes people get these two confused because they're like, horizontal, why is it y? Because the horizontal axis is x. But remember, the line is not the axis. So when we say y equals 43, we're saying y is 43 and with any x. So you plot a few values with y equals 43 and any other x, you're going to end up with a horizontal line. So I've got some questions for you to try on your own, and I will post the answers.